In this section, we're going to talk about your resistivity and Ohm's law. So we are not going to talk about complex circuit. That's in another video. So for Ohm's law and resistivity itself, let's double check what this means. Now, for this over here, this Ohm's law depends on school. Basically, you might need to memorize. Okay, depends on the school itself. Because basically what this actually just means is I is V over R, where I is 1 over R D. So you can see this is actually the same as kind of like a graph where y equals to mx. Normally we have a plus c, right? But we just assume that it's 0. So you can see that your gradient is actually 1 over R. So your gradient is 1 over R. It is not resistance R. Okay? So this is actually going to be a constant. Okay? So if you obey Ohm's law, what does it mean? If you obey Ohm's law, you will actually end up with this graph. Do take note, this is IV graph. Okay, your gradient is 1 over R. This is a constant because you have a diagonal straight line. So you have a straight line itself. What does that mean? It also means R is constant. So if you obey Ohm's law, your resistance is constant. Okay. Now, on the other hand, if you do not obey Ohm's law, your resistance is not constant. Does that make sense? So you can see over here, my gradient, right, is actually decreasing. Okay, and don't forget, what is your gradient? Your gradient is 1 over R. Since 1 over R is decreasing, which means R must be the opposite. R must be increasing. So in this case, what actually happens is when temperature increases, resistance increases. This is mostly for your filament light bulb. So if you look at the light bulb itself, the one that has this one, basically if you keep heating up, your resistance will increase over time. Okay. Then next one is your semiconductor diode. Now this is actually a very, very special device. Because of the shape that it has, what's so special about this is that it only allows current to flow in one direction, which means you force the current to only move to the direction that the arrow is pointing to. So you see this shape is like a direction of which current that it allows to flow. If you try to reverse the direction of this over here, what happens is you will be met with the door. So it's kind of like a valve of your heart. Basically, it's a one-way trip only. So if you try to go the other way around, door there, the line blocks you. So it cannot flow. Which means if I want to use negative voltage, basically I flip the direction of my battery, it's not possible. This is 0A from this part. Okay, so because there's no current itself, you cannot flow. So it can be the other way around only. So in this case, you can also see exactly the same step. Gradient is also 1 over R, right? And this is increasing. Now, why is gradient always 1 over R? Because this is an IV graph. Okay, so in this case, if 1 over R is increasing, what this means is R is decreasing itself. So if R is decreasing itself, you can see that basically the more voltage you have, the smaller the resistance. And if you have too much current, what happens? If you have so much current, your light bulb, your diode, your semiconductor diode might actually explode. So just be careful. Once you reach a certain point, it will explode. So please be careful about it. Okay, so just remember, as temperature increase, resistance also increase. So this line here, temperature increase, resistance also increase. Okay, so you can just imagine it's like an obstacle course, right? Remember your wires look like this. So your electrons are trying to travel down this path. But in between them, inside the wire, there is all your metal particles, right? So you can just imagine your particles. If you gain heat, all of them, your particles, right, are basically moving faster and faster. So it's like a obstacle course, but then basically they are super duper fast. So it's more difficult. Since it's more difficult for you to flow through, don't forget, current is the flow of electric charges. So if it's more difficult to flow through, you will have more resistance. Okay, so ultimately, you just need to know the first line itself. In rare cases, they'll actually ask you to describe why. When temperature increase, your resistance also increase. Okay. So next part is actually talking about your resistivity itself. So basically, this is an expansion of your resistance of the wires, because previously we learned that resistance of the wires, you have these two that affects it, right? But now we're going to learn a third one, which is your resistivity over here. Okay. So this one is depends on the material. So if I use the same material, okay, let me just write. If I use the same material, what does it mean? Equals to same resistivity. Now, do take note, this is not resistance. This is resistivity. It's a different quantity. Okay. So if I use the same material, I use copper and copper, same resistivity. So we're not going to be affected by it. But if you use silver and use copper, they will have different resistivity itself. So do take note about this. So you can see the relationship down here. The lower the resistivity, the lower the resistance. Okay. So let's take a look. Number one, we have your length. Okay. And you have I. What's the resistance of the wire? So first thing, we have V also, right? So R is V over I. So basic 3 divided by 0.15. So let's press your calculator to double check the values. Should end up with 20 ohms. Okay. Now, the question now tells us is length is doubled and your cross-sectional area is half. So new L is 2L. New A is half A. Okay. So what's the new resistance of your wire itself? So you can see, first thing, if we just remember the formula on top, is this formula, right? Rho L over A. So you can just imagine this is your original. So I want to find new R. New R, I have the same resistivity because I'm using the same wire. Then my L is now 2L, and I will use half A. Okay. So if you were to extract out the 2, and you have this, it is 2 divided by half times rho L over A. Make sense? So if you actually press 2 over half in the calculator, you end up with 4. And this rho L over A is R, right? On this side, the left-hand side. So you can see this is actually 4 times 20, which is 80 ohms. So you actually have 4 times the resistance of your original amount. So previously, when we learn it in our normal notes itself, right, we know that as L increase, R also increase, right? And as A increase, so as A decrease in this case, R will also increase, right? So what happens if I have 2 times the L, it means I have 2 times the R. If I have half the A, I will have 2 times the R. So 2 times 2, you give me 4, right? So ultimately, I have 4 times the R itself. You can see it in this case. Okay, this one is a separate method. Basically, this is a super basic version, but basically, we are actually deriving it off this formula. Okay, so if your maths is not so good, you can take a look at this, but this one very easy to get careless because some students 2R times 2R, I get 2R squared. No. So this is just the multiplier because I have 2 times the resistance, I have 2 times it, so 2 times 2 is 4. Don't need the R. Okay, so if your value now is, you want to find your new I, right? I'll need to use new V or new R. So V didn't change because I'm still using the same battery itself. So I'm still 3, and now I divide by 80. So what's your value? 3 divided by 80, I'll get 0.0375. And depending on some schools, you might need to round it up. And current, this is 2SF. Okay, so depending on some schools, you might need to use 3SF. Some schools will use 2SF itself. But typically, most schools will actually use 2SF. Okay, for the students who have this part of the in their notes. Okay, so if now, different question already, keyword is diameter now. Okay, so diameter is for the original wire. So first thing is you want to find your radius, right? Radius is half. Diameter is 2.5 mm. And because we're going to use a formula, let's change this to SI units first. We'll divide by 1000, so 0025 meters. Let me just double check. Yes, 0.0025 meters, right? So next, you want to use your area. You want to find area first. So area is pi r squared. So we're going to use pi r square, right? So you will end up with a very, very small number. So 0, 0, 0, 0, 1, 9, 6, 3, 5. Well, let me just check. How come my 0, 0, 0, 0, 1, 9, 6, 3, 5. Yes, okay. Just clean up. 6, 3, 5. This is 9. Okay. So this is your meter square. So next is we want to find resistivity, right? R is rho L over A. So rho, if you flip it around, is RA over L. So all we need to do now is put in our numbers. What's resistance of the original, right? Original is 20, area is 0 0.00019, and your length, we use 50 cm. 50 is 50 over 100. Change it to meters, right? So 20 times 0.000019635, and we're going to divide the whole thing by 50 over 100. Okay, so you should end up with 0.123784. So with that, let's double check the values. Because we're going to use 2SF, we're going to 0.00079. And this is resistivity, so we use ohmmeters. So let's just double check. Yes, this is the value that we have. So you can see over here, your resistivity is actually quite small. So just be careful when you're dealing with so many small little zeros. You can actually use fractions, and only your final answer, you change it to your 2SF, which I forgot. So minus 1 mark. Okay. So your steps a bit messy, but basically this is the gist of it. Remember, when you use any formula, make sure that you use SI units. Okay, so resistivity is just another factor to add on to the relationship that we have over here. Okay, but because if they ask you to calculate the formula, calculate the resistivity, then you need to be very familiar with this one. Okay, but in most schools itself, they don't actually teach resistivity. They just teach you about the relationship between length, area, and your resistance. So do be careful. If you ever give you diameter instead, you need to find your area using the pi r square formula, because your wires is a circle, it's a cylinder. Okay,